Hello everyone, I should be live now, and hello everyone, I should be live now, and okay, I hope everyone can hear and see me clearly. If that is the case, you can just type yes in the chat box. Can you guys hear and see me? You can? Okay. All good? Yeah, I'm good. How is everyone? How are you all? Did you get some time to try your hands out on this question? How many of you tried to solve this question on your own? Okay, that's great. Could you come up with some solution to it? Any approach? I'm pretty sure a lot of you would have come. So why don't you just mention it in the chat? Just feel free to write your solutions in the chat, and probably we'll pick them one by one, we'll discuss them, and then we'll take small steps towards the final solution. Okay, let's do that. I'm waiting to read your solutions. Okay, so meanwhile I'll mention a lot of solutions that I got to hear from a lot of people. So I think if you read the question, the problem statement is quite clear. It says that we are given a string S and we are supposed to remove duplicate letters so that every letter appears once and only once, and you need to make sure that your result is the smallest in lexicographic order. That's the most important thing. So for example, let's say you have been given a random string which is let's say double B, A, B, C, D, C. So the first requirement is that I don't need any duplicates. Every letter, as you can see here, should appear only once. So B, which is coming for 3 times, should be coming only once. Similarly, A, it is already coming once, so yeah, A should also come just once, and the other characters also like D and C, they should also be appearing only once. This is the hard and fast requirement, that no duplicates are allowed, every character appears only once. And on top of that, we need to make sure that our result is smallest in lexicographic order. So do you guys understand the meaning of lexicographic order? What is lexicographic order? Lexicographic order is same as dictionary order. So if you look at dictionary, in dictionary the words are sorted, correct? So for example, if you are going through a dictionary, which word will come first? Will you have a word AC or will you have a word CA? Which one comes first in dictionary? AC will come first, right? it's smaller than CA in terms of lexicographic order. So see, let's say you consider this input itself, which is BCABC, right? Now, the first thing that I wish to tell you here is that you are allowed to remove any number of characters, correct? You're allowed to remove any number of characters, but after removal, you are not supposed to reshuffle the string. You are not supposed to rearrange the characters. So not supposed to rearrange the characters. So what I mean by that is, let's say this is what your string is, and if you have chosen to remove, let's say C and B. So if you choose to remove this C and that B, what will be the result? The result will be BAC, correct? Now you can see it quite clearly that after removing C and B, I did not rearrange these characters. I did not change their relative position. Now what a lot of people do is they also go ahead and change the relative position, which is they rearrange. So if they rearrange, they can easily get something like ABC, and they will say that ABC is answer. Now in this question, for the context of this question, you are not allowed to do so. You can remove as many characters as you want, but from the result, you cannot do rearrangement of characters. So this is a very, very important point to understand. By the way, is that making sense? How many of you get this point, that rearrangement of characters is not at all allowed? Okay, so if you understand this point, then a very well-known solution that a lot of people come up with will automatically get discarded. So I'll tell you what a lot of people say. They say that, hey, what we will do is we will simply sort the string. We'll sort the string, and whatever will be the answer, that will be the real answer. And in fact, one of you is also saying that increasing in sorted form. So if you go ahead and sort, first of all, we'll understand that why this very idea of sorting comes up in our brain. Why it comes up? Because what is a string? String is nothing. It is merely an array of characters, correct? It's an array of characters. Now, forget about array of characters for a moment. Let's say you have an array of integers. This is your array of integers. 1, 7, 5, 4, 3, 6. Now, if I ask you to rearrange it in a way, somehow rearrange it in a way that you get the lexicographically smallest value, what will you do? You will simply sort it. Sort in increasing order. And whatever you will get, that will be your answer. So going by this thought, lot of people are tempted to come up with this solution that, hey, whatever input I have, I will first sort it. But given that sorting is not allowed, rearrangement is not allowed, so this solution will fail. You are not at all supposed to sort. Sorting based solution will not work basically. That is the first point to understand. I hope everyone gets that, right? Why sorting based solution comes to our mind, that is the first thing. And second thing, why it is not going to work in this case. Why? Because rearrangement is not at all allowed. Okay, so let's think of it in this manner now. Let's say you have been given an input, you have been given string S, and for now your string S is a special string which only contains unique characters. So I'm writing it here. It only contains unique characters, and that too in ascending order. So let's say your string is something like A, B, N, Y, Z, something like this. In this case, what will be the answer? Can you tell me? If your input string is this, which contains unique characters which are sorted in ascending order, what exactly will be the answer? And you can take this as an example. Can I say that, hey, the original string itself will be the answer? Yes or no? Correct? Yeah. because this is the smallest permutation, this is the smallest string that you can get by taking these characters into consideration, right? So what does it mean? It means that if we have a string, or for that matter, if we have a portion of string which is sorted in ascending order, then do not disturb that portion. Why do not disturb that portion? Because if you disturb it, you will end up getting something which is lexicographically greater for sure. Correct? So if a string is already sorted or a portion of it is sorted, then it's good for us. In that case, there is no work which is needed from our side. Can everyone realize this point? Okay, now we will go one step further in this. So now we will say that, okay, the characters are sorted in ascending order, but there can be duplicate characters also. For example, let's say A is coming thrice, B is coming twice, N is coming once, and Y is coming for 4 times. So in this case, what will you do? How will you solve this question? I would say still it is super easy. All that we will do is we will just consider one instance of A. So we will see that there are 3 A's which are coming consecutively, but we will only take one A in our answer. Similarly, there are 2 B's which are coming, but we will take only one B. Similarly, there is only one N, we take only one N. There are 4 Y's, we take just one Y. So even this problem can be solved. So as long as the characters are sorted in ascending order, this problem is very easily solvable. But if we have anything random, in that case, things can go haywire. So let's say this is the string that you have at your disposal. And now what do we want? We want to ensure that every letter appears only once. So I have to remove certain letters, right? So can I do something? If I just remove this B and C, what am I going to get? I am going to get BCA. Now if you look at this BCA, every letter is appearing only once inside it. But is it the smallest possible value that you could have gotten? Is it the lexicographically smallest string that you could have generated? Just think about it. The answer is no. Why? Because instead of removing this BC, how about you remove this BC? So if you remove this BC, in that case you will end up getting what? You will end up getting ABC, and that is the smallest answer. So now the question is giving us a feeling that, hey, there can be multiple ways of removing duplicate characters, right? But some of the ways, like this way, is giving you a result which is larger than the other way. What was the other way? The other way was to remove these 2 characters. If I trim these 2 characters, my result is ABC, and that is the best possible result. That is the result that we all want. So now we have to come up with an algorithm, we have to come up with a logic which ensures to give us this kind of result only, which is the smallest possible result. Okay, just to keep everyone on the same page, I'll ask one question, that is everyone clear with the problem statement and all these things that I have explained so far? Yes or no? In the meantime, I can just read what a lot of you have written in chat box. 2-pointer approach. See, whenever you say I'll use 2-pointer approach or sliding window approach, or for that matter any approach, make sure that you have a very, very concrete logic behind that. Why do you want to use 2 pointers? Why do you even think that will be helpful? So answering such questions will be super important, right? Okay, so till now everyone is clear with the question. That's great. That's great. So now we can move ahead. Okay, so let's start thinking about this question. Is always removing duplicate elements from front correct? So somebody is saying, is it always correct to remove duplicate elements from the front? Will that be a right idea? Can I say that it's always a good idea to do that? Let's see through some explanations. Okay, let's say I have got a random string Okay, and this string for now has some characters inside it. Those characters are, let's say, P, Q, R. Okay, and then let's say you got something like A, and after that you have Z, P, Q, R, something like this. This is what you have for now. Okay, what will be the answer in this case? What is the smallest possible string that you can get for this case? So here a lot of you would say that, hey, what we'll do is we can see that this PQR is getting repeated. So it's better to, let go of this PQR. If I let go of this PQR, I'll get AZPQR, and that looks like the smallest possible string that we can ever get, right? Okay. Now, let's say the string was given to you. You pick this string up, right? After picking this string up, what you did, you considered the first character. You considered the first character, you kept it somewhere. So let's say you kept it here, right? Now, you just move on. You move on to the next character. The next character is Q. See, the next character Q, how does it compare against P? Is Q greater or smaller than P? I mean, in English alphabet, does Q come before P or does it come after P? It comes after P, right? So if you see that you are getting a character, if your current character is greater than the previous character that you have, in that case, there is no harm in keeping it. Why there is no harm in keeping it? Because rearrangement of these two things will not do any profit to you. If you rearrange this P and Q and you end up getting QP, then that will be lexicographically larger. So back to the basics. What was the basics? The basics was that if we have a string or a portion of string which is sorted, which is already sorted, then you do not need to disturb that. Okay? So once I found that this Q is greater than P, I simply considered this Q also without doing any fuss about it. Okay. Now, let's move on to R. How does R compare against Q? You see that R is also greater than Q. So yeah, you will go ahead and you will consider this R, right? Okay. Now you come to this A. How does A compare against R? Is A greater than R, smaller than R? What it is? Quite clearly, A is smaller than R. Now, if A is smaller than R, what should I do in this case? What should I do in this case? Just think of it in this manner. During this point of time, I need to check whether this R is coming after A or not. Because if this R is coming after A, that means we can get rid of this R, correct? Because we all know that, let's say there is a string which is starting with PQR, and then there is a string which is starting with PQA. If I call it string 1 and call it string 2, which string is smaller? Is string 1 smaller or is string 2 smaller? String 2 is smaller because PQA, any string starting with PQA, will be smaller than any string that starts with PQR. So the point that I am trying to make is, if you get a character like you got A here, which happens to be smaller than your previous character that you have chosen, and on top of that, if this R is coming in the later part, then we can kick this character out. So I am just writing whatever I have spoken. If our current character, okay, if our current character happens to be smaller than our previously considered character, which happened here, like your current character is A and it happened to be smaller than your previously current character. In this case, what do you need to do? You need to check if your previously considered character is coming in future or not. By future I mean is coming in the later part or not. If it is coming in the later part, then you can knock this character off. Correct? Now, the same thing that you did for R, you can do for Q also. What I mean by that is, you can now go on to compare your current character A with your Q. So what will happen? What will you see? Will this condition hold true for the comparison of A with Q? Yes or no? What do you say? Is A smaller than Q? Firstly, the answer is yes. Moreover, is Q coming in future? The answer is yes. Q is coming out in future. What does that mean? That means we can get rid of this Q. And what is the logic behind it? The logic is that any character, any string that starts with PA and then has Q coming later will be smaller than any string that starts with PQ and then has A coming later, right? Now the same thing can be repeated for P also. You can say that, hey, when I compare this A with that P, I can say that this A is smaller, and on top of that, this P is appearing in the future. Because it is appearing in the future, we can let go of this P also. And now because it is empty, all the characters have been knocked out, so I can simply put this A here as it is. That's it. Job done. Okay. Now we will move on to the next character, which is Z. How does Z compare with A? Is it greater? Is it smaller? It is greater. Because it is greater, we will push it as it is. Right? Now come to P. What is your current character? Your current character is P. Right? And what is your previously considered character? Your previously considered character is Z. Now, how do P and Z compare with one another? Tell me. Is P smaller than Z? Yes. So I can say this condition is true. Now, if this condition is true, can I just knock this Z away? Can I kick it out because this condition is true? Yes, no? Will that be the right thing to do? Not really, because we need to check. We need to check whether this Z is coming in future or not. Tell me, is this Z coming after P? No, it is not coming after P. Because it is not coming after P, what does it mean? We can't kick it. Because the requirement of the question is that every letter appears once. So if you kick this Z out, and if it is not coming in the future, you will never get that. So this condition is super duper important. So in this case, we will simply push P and move on. Now we see we have Q. How does Q compare? How does Q compare with P? Q is greater than P. So we will push Q. How does R compare with Q? R is greater than Q. So we will push R. And this way, this is the solution that we have gotten. This is the smallest possible answer that we have gotten here. So what is the core idea? What is the key idea? The key idea is that we need to somehow keep track of some facts. What is the first fact? That whenever we are at a current character, let's say this is our current character, we need to know what is the frequency of other characters in the remaining part. I mean, we literally need to know. See, if you have to know whether Z is coming in the later part or not, or Q is coming in the later part or not, or M is coming in the later part or not, how will you be able to achieve that? You will only be able to achieve that if you know their frequencies. So the first requirement is that I need to somehow maintain the frequencies of the characters. That's the first requirement. Maintain frequencies of characters that are going to come in the future. Does everyone understand that why this frequency array, or instead of using a frequency array, you can also use a hash map? It's up to you. But why it is needed, do you all understand that? Right? Okay, great. Now, there is a question, but if string is APRP, in this case answer will be APRP. Your answer will not be APRP. If you read the question again, it says that every letter should appear only once. Okay, duplicates are not allowed. Yeah, you are asking about the duplicates case. I'll talk about the duplicates case. See, whenever you encounter a character which you have already pushed somewhere in your answer, you can simply ignore that character. Okay. Okay, how about taking some case up and then working away with that. So let's say you have, I'm just going to alter this string a bit. So let's say you did not have this Q here, you did not have this P here. Okay, what will be the answer, by the way? Can you guys type your answers in the chat box for this question? Will there be a separate case for comparing the first character? Not really. Anyone who could figure out the answer to this? Okay, so while you are so somebody is saying AZR. If you're saying AZR, PQ are not there. Read the question. Every character should come once. So you're not considering PQ at all. Okay, somebody is saying PQRAZ. Okay, and then somebody is saying APQ. See, after A you cannot have PQ. You understand that? Because we talked about it, we are not allowed to rearrange the characters. You just can't do that. How about this PQAZR? Does that happen to be the real answer? Okay, so let's talk through it. Okay, so what we'll do, we'll move ahead and we'll pick a character as our first character. So let's say you have picked up your first character, that is P. Now you move on to the next character, which is Q. So your current character is Q. Now how does Q compare with P? Is Q greater than P? The answer is yes. Because Q is greater than P, you will simply push it. How does R compare with Q? R is greater than Q, so you will push this R. The segment which is sorted, life is very simple with that segment because we don't need to disturb that. We don't need to do anything to it, right? Okay, at this point of time, your current character is A. Your current character is A. And your previously considered character is R. Is A smaller than R? The answer is yes. Now, is this R appearing in future? Is it coming in future? The answer is yes. Because it is coming in future, can I knock it off? Can I knock it off? The answer is yes. Now you need to understand why we are knocking it off. I'll give you the same explanation that I gave you before. Because a string that starts with PQA is any day going to be smaller than a string that starts with PQR. So knocking this R in favor of that R is a wise decision to make. Correct? Are you getting the point? So what we'll do is, after realizing that this A is smaller than R and this R is appearing in future, we will kick this R out. After kicking this R out, we will repeat the same process with A and Q. Okay, so what is your current character? It is still A. And what is your previous character? It is Q. Is A smaller than Q? Yes. But is this condition true? Just look at it and say, do you see that this Q is appearing after A? The answer is no. Because it is not appearing, so can you kick it off? The answer is no, you can't kick it off. So in that case, you will simply push this A over here. correct? Now, what's your next character? It is Z. And how does Z compare with your previous character? It is larger. Because it is larger, simply push it. That's it. Now move to the next character. What is the next character? It is R. How does R compare with Z? R is smaller than Z. So this condition is true. R is smaller than Z. But is this Z appearing in future? No, there is no future here, right? So you can't knock it off, because if you knock it off, you will not get it back. So in that case, you will simply push it. This is the idea. This is the core idea. I hope with help of this and that example, you'd have got the gist of basic, the most important idea, right? The most important idea is that if you are getting next character as greater than the previously considered character, you can safely push it. But if it is smaller, then you can knock it off only if the previous character is appearing again in the future. That's the idea. The previous character was this if it's appearing again in the future. We'll talk about the time complexity part. All that will happen. Don't worry about that. But is this core idea clear? How many of you are absolutely clear with this core idea of how to phrase the smallest possible string? You can say yes, or you can ask questions. Okay, great. Cool. Now that we have understood this entire thing, a lot of you were asking question about, hey, what to do about the duplicate characters? What if a duplicate character is there? Of course, duplicate characters can be there and you have to handle them. You just can't let go of them. So I would say, if there are duplicate characters, you don't need to worry at all. Like, let's say you had a last character over here and that character was Q. Okay. So you'd now say that, hey, now my current character is Q and my previous character is R. What I'll do is I'll quickly go ahead and check whether this character has already appeared or not. If this character has already appeared, then there is no action that I am supposed to take. Okay. So this is an important thing. If our current character is already a part of our answer, then nothing needs to be done. So by that I mean we can just simply skip. We can simply skip that character. Okay, and you can take any other example also to better understand that. So let's say you have got A, C, A, B, C, D, something like this. Okay, in this case you will say that, okay, let's start with the first character and put it somewhere, which is A. Now your current character is C and C happens to be greater than A. Because C happens to be greater than A, you will simply consider it, you will simply push it. Now you get this A. Tell me, is this any use of considering this A? Does it serve any purpose? Although this A is smaller than C, and you see that this C is appearing again in the future. So if you go by that logic, you might want to pop this C off. You might want to remove this C off. But is there any use of that? There is no use, because you have already considered an A before. So, I mean, you're already going to get a string starting with AC, and that way also you will go on to get a string starting with AC. So there is no purpose of that. There is no use of that. So I would say that whenever we encounter a current character which is part of our answer, take no action. Simply skip it. So the first thing we realized was we need to maintain a frequency of characters. Now there is another thing also that we need to somehow ensure. I'll tell you what. So in this particular case, let me ask you, what should be the choice of your data structure? Which data structure would you want to choose to solve this question? I mean, the way I told you that we knock off the characters from back and all such sorts of things, which should be the most ideal data structure? Stack. Why should stack be the most ideal data structure? Let us understand that. See, I told you one thing. Let's say we are trying to create our answer, and so far we have considered these characters PQR. Now, when you get this A, you always want to compare your current character with the topmost character, isn't it? And after comparing with the topmost character, if you see that it can be knocked out, you want to knock it out. And then again you want to compare with the next topmost character. So this is the journey that you want to take, right? So whenever you feel like you are dealing with a question where you need to always compare with topmost character or topmost item, then stack is the best data structure to use, because stack gives you quickest possible access to the topmost element, isn't it? So what I'll do is I'll say that I'm going to use a stack. So imagine that I'm going to use this portion as a stack for now. In this stack, I'll push my first element, which is P, correct? And then I'll compare this Q with P. I'll see it is greater, so now I'll push Q on top of P. Now I'll see R is also greater than the top of the stack, so I'll push this R. So far this is the stack that I have, correct? Now I have got A as a character, so I'll compare A with the top of the stack, and I'll see that my current character A is smaller than the top of the stack. Because it is smaller than top of the stack, so I would want to check whether this R is appearing in the future or not. If it is appearing in the future, that means I can pop it from the stack, and pop, push, all these operations in the stack are order one time operation, correct? Cool. Now I'll repeat the same comparison of A with Q. Let's say this Q was coming later. Like in this case, you can see that this Q is coming here, right? I mean, your current character is A, and it happens to be smaller than top of the stack. And moreover, the top of the stack is Q, which is coming in the future. So it means I can let go of this Q also, correct? Now I'll compare this with the top of the stack, which is P. And I'll see that, hey, although it is smaller than P, but P is nowhere appearing in the future. So I don't have any right to kick this P away. So what I'll do, I'll simply push this A inside the stack. So guys, do you understand why I am using a stack? I am using a stack because I always have to compare with the topmost character, and I have to pop it, and popping from the topmost end happens in order one time in stack. And I also have to push at the top. So I mean, if I have to delete a character, I have to delete from the top, and if I have to insert, I have to insert also at the top. That is the reason I am using a stack instead of any other data structure over here. It's very, very intuitive to use stack here. Of course, you can manipulate an array or vector and get the same functionality, but if there is an inbuilt data structure like stack which tailor makes these solutions for you, why not use it? How many of you understand this point? How many of you get it quite clearly that stack is the right guy, the right data structure to use here? You can say yes if you get that. Okay, coming to the part where I told you we need to maintain a frequency of characters. For this, what we can do is we can just have a simple vector of integers, right? And I can say that, you know, I want every character's frequency, right? Now a character denotes an integer in its ASCII code, isn't it? And ASCII codes are in between 0 to 255. So I can say that I can create a vector of size 256 where all the elements are 0. Okay, I can do that. So let's say I create a frequency vector like this. It means that frequency of 0 is 0, frequency of 1 is 0, and frequency of 255 is 0. Everything's frequency is 0. Now, while we are scanning the string, we can do frequency of s of I++. So all of you know how to go ahead and create a frequency array, right? I'll be writing the code for that, but don't worry about it. I can quite easily do that. So once we have a frequency array with us, then the job is very easy. But However, I'll tell you one thing. Here it says we need to check whether previously considered character is coming in future or not. So at any point of time, the frequency array should reflect the frequency of future. That means if your current character, for instance, is Z, your frequency array should say that P is coming once, Q is coming once, and R is coming once. It should not tell you that P is coming twice and Q is coming twice and R is coming twice. So we need to somehow keep on updating our frequency array. It's very important, because if you don't keep your frequency array updated, it will not tell you about the future, it will tell you about the entire string. And it is a very, very important point to understand that why I am asking you to maintain a frequency array and keep updating that. Do you understand this part? Why updating it is required? You can say yes or no to it. And you will realize it is super easy to do so. Super easy to do so. How? Let me tell you. Let's say you are scanning this string. If you are scanning this string from here to here, once you are at the first character P, you can do frequency of P minus minus. Similarly, when you reach at Q, you can do frequency of Q minus minus. Basically, as you are sliding along this string, you can simply do frequency of that particular character minus minus. See, once you create this frequency array, how will it look like? It will tell you that, you know, the frequency of P is 2, because P is coming twice, if I am not wrong. Similarly, the frequency of Q is 2, because Q is coming twice. This is the data that it will give you, right? But if you read this line, I told you that at any point of time, we need to know the frequency of remaining part, the frequency of remaining suffix, which is the future. So I need to keep on updating my frequency array, my frequency vector. So all that I am saying is, as you are sliding across this string, you need to keep on subtracting the frequency of that particular character. So whenever I am at, let's say, index I, I'll do frequency of S of I minus minus. It is super important to do it. If you do not do it, your frequency array will not be consistent with your future. Do you now understand this point? How many of you clearly get it, the importance of doing frequency of S of I minus minus? Yeah? Okay. So that was a thing which a lot of people miss out on. Now, the next thing. I told you that if we end up finding a character which is already a part of our answer, then nothing needs to be done. We need not do anything. Okay? Now, how do you check whether a character is already a part of your answer or not? How do you check that? Like, for example, if you go back to this particular input only, what did you do? You started with P, and then you saw that Q is greater than P, so you inserted Q. Then you saw that R is greater than Q, so you inserted R. Now, when you were at A, you realized that A is smaller than R and R is coming in future, so you kicked this away. Now, you compared A with Q and you found that, hey, Q is also coming in future, so you kicked it away. You compared A with P, you found P is coming in future, so you kicked it away, right? Now, the next character was Z, it is greater than A, so you pushed Z. Now, the next character is P. Now, you need to have a way to easily check whether this P is already a part of your answer or not. Tell me, is P a part of your answer at this stage? Is it present? The answer is no, right? So how about having a Boolean vector? There can be a Boolean flag sort of thing of the same size 256, which is initially all false, false, false. And now what we will do is, whenever we insert a character in our answer, we will do flag of that character equals to true. For example, if you insert this Z, you will simply do flag of Z equals to true. So that if in future you encounter Z again, you can consult this flag to check whether it is already a part of your answer or not. If it is a part of your answer, nothing needs to be done. Also, whenever you are kicking the characters away, like here you saw, after you had inserted PQR and after this A was one by one kicking them out, then it was very important to change their flag. It was very important to say that, hey, now that flag of R should be made equal to false. Similarly, flag of Q and flag of P, once they are kicked out, should also be made false. So the important thing is that whenever a character is inserted, I need to update its flag to true, and whenever it is kicked out, I need to update its flag to false, because if you had not updated their flag to false, once you would have reached this P, you would have seen that, hey, it is still true, and you would have been in trouble. You would not have considered that. So it is very, very important to maintain this flag, array, which is a Boolean array, and keep it updated. Do you understand this point, that why this flag array is needed for the purpose of this question? Okay, so summing it up, overall, what we need is, we need a stack of characters, we need a frequency array, and we need a flag array. These are the three requirements that we have if we want to solve this question, right? Okay, now how many of you, can you guys take out your pen and paper, or you can take out your IDE on your computer and try writing the code on your own. Try writing at least the pseudocode on your own. Everyone should do that. Write some pseudocode, take few minutes, and then after a couple of minutes or so, I'll write code along with you. Give some try to it, okay? Okay, so I'll start initializing important things which are needed to solve this question. So tell me, what was the first thing that I needed? I needed a vector of integers which was supposed to store the frequencies, right? So I'll have a frequency array of size 256, and initially all the frequencies are 0. Apart from that, I'll have a vector of Boolean, okay, and I'll call it taken, whether the character is taken or not in our answer. And this is also of size 256, and initially everything is false because initially nothing is taken, okay. Now what I'll do is I'll initialize my frequency array, and doing that is super easy because all that I'll do is I'll go ahead and scan my string from head to toe, s dot length I plus plus, and I'll simply do frequency of s of I plus plus. Now what does it mean? By the time this particular code is over, I would literally have stored frequencies of all the characters that are present inside this string s inside it, right? Okay, the next thing I'll do is I'll go ahead and create a stack of char, call it stk for now. Not a great naming, but I'm just writing it all quickly. And now to start with, I'll push my first character. My first character is s of 0. Now that I have pushed my first character s of 0 inside the stack, don't you think I need to update the value of frequency and taken for s of 0? Just imagine your s of 0 was p, and if you have taken this p, then you need to update the frequency of p that is appearing in the future. For that to happen, you need to quickly write frequency of s of 0 minus minus. And also to demonstrate the fact that s of 0 has already been taken, you need to change taken of s of 0 to true. Now I can say I have a stack which has been initialized. So now there is an item called as P inside my stack. Imagine this was your stack and you have an item called as P in your stack. Now you can start iterating from this character onwards. So you can start your iteration from index number 1. So you can write int I equals 1, I smaller than s dot length, I plus plus. Okay. Now tell me what needs to be done. So I'll write few conditions and you will tell me. Do you remember this check that if a character is already a part of our answer, nothing needs to be done? Imagine if there was a P after this P, then no action was needed, right? So if we end up finding that if the taken flag for s of I is true, if it is true, what do I need to do? Do I need to take any action? No action. Probably all that I can do is I can just do frequency of that character minus minus and that's it. Frequency of s of I minus minus, because we need to keep our frequency updated and we need not do anything else. Nothing else needs to be done. So this P will simply get ignored. That's it. Okay. What to do in the else case? Tell me. In the else case, as I told you, again, let's imagine the scenario when you had already pushed P and then Q and then R. Okay. And now your current character was A. So if your index was pointing to this A, what do you need to do? You need to constantly keep on comparing this A with the top of the stack, and then you need to perform this check. And based on that check, you need to kick the element out of the stack. So I'm just going to write a while loop because I need to not only do that thing with R, I also need to do that with Q and P all the way till my stack becomes empty. So I would say, hey, while there is a condition, while the top item of the stack happens to be greater than the current character s of I, and as I told you, as I explained you, I need to check whether that character, the topmost character, is coming in the future or not. So how can I check that? Thanks to the frequency array, I can just write frequency of stack.top positive. So if this condition and this condition both are true, then what does it mean? Can you guys say? What does it mean? If both these conditions are true, it simply means that yes, we can kick that character away. Okay, we can kick that character away. Now, when you are kicking that character away, the stack gradually keeps on getting empty, right? So I'll come to that part, but before that I would say that, okay, because you're kicking that character away, so let's do one thing. Let's say that taken flag for that character, which is stack.top, has to be made equal to false. That's the first thing. And then remove it from the stack. See, if you're looking at the code, I am doing nothing else than whatever I have explained. It is exactly the same thing. Okay. Okay. Now in this while loop, I'll tell you one thing. While you are doing this operation, the stack might eventually get empty. When the stack gets empty, and during that time, if you do stack.top, what will happen? You will end up encountering underflow, stack underflow. So it is very important to check that the stack should not be empty. So I need to put a condition while not of stack.empty, and on top of that, so as long as these conditions are true, I can keep on eliminating the item from the stack. Okay. And now after this while loop, what I can do? Now finally I feel comfortable enough in pushing the current element. What is my current element? It is s of I. So now I can write stack.push of s of I. And once I have pushed something, I need to repeat these two logic, because if it has been pushed, then if it has been firstly considered, then the frequency of the future needs to be updated. So I need to write frequency of s of I minus minus, and I also need to write taken of s of I equals to true. If you look at this piece of code, this for loop, then this for loop has made sure of the fact that only the characters which are unique have been put up in your answer. The duplicates are discarded, and this particular logic has made sure that the smallest possible item, the smallest possible substring, the smallest possible string, or call it subsequence, has been generated. So now the thing is that your stack contains your answer, your stack contains your actual answer, but you know, stack has been populated from bottom to top, right? So it means that, let's say if your answer was, let's say if it was A, P, Q, Z, R, then your stack would have had A, P, Q, Z, and then R. Now the important thing is that we construct our string. So in order to construct our string, what we can do is that we can put all these characters inside the other stack, and then from the other stack we will, why we are putting inside the other stack, because if you put inside the other stack, then the first character will be at the top and last character will be at the bottom, and then we can create the string by concatenating the characters one after the other. So what I am going to do is I am going to just go ahead and create a temporary stack for now. I'll call it temp, sorry, the stack of character, temp. And now I'll simply say while my original stack is not empty, while not of stack dot empty, I'll simply keep coming here and I'll say temp dot push stack dot top, and then I'll do stack dot pop. That's it. Now it means that all these characters have been put in the other stack in the desired order. I mean, the topmost character would be A, then P, then Q, then Z, then R. Now nothing special is left. Now we can just initialize a string answer which is initially empty, and now one by one we will empty the other stack, which is temporary stack. So I would say while not of temp dot empty, we'll simply go here and we will say answer plus equals to temp dot top, and then temp dot pop. That's it. And then finally we can go ahead, return our answer, run the code, check whether everything is good or not, and submit the solution. It has been accepted. So this is how the code finally looks like. Okay, cool. So does it make sense? How many of you have been able to relate the idea of code with the algorithm that we have discussed? There is a question, why did you put stack empty on the left? See, inside this while loop, what are you doing? You are emptying the stack. Once you are calling stack.pop, elements are being eliminated. So can't it so happen that the stack has been completely emptied? When the stack is completely emptied, and let's say you do not have this check, and during that time if you do stack.top, what will happen? Underflow, because you are trying to fetch something from the stack which is empty. So this condition is needed, and keep it as a rule of thumb. Whenever you are writing a code that deals with a stack and does things like stack.top, stack.pop, then the first check you need to have is to check whether your stack is already empty or not, right? Yeah, there are multiple other ways. It's up to your convenience. I mean, the core logic was still here. After that, whatever I have written, it can definitely be optimized. The most important thing that I wanted to convey was in this part, this logic. Okay. Okay. Great. Why are you taking first character separately? See, I need to initialize my stack with something, right? Even if you do not initialize, no issue. I mean, even if you do not do that, then this code should run fine. But I did that to be consistent with my explanation. When I was explaining, then I always told you that we always first pick the first character, put it inside the stack, and then perform our journey with the remaining characters. Okay, let's move on and talk about the time complexity of this part. So usually whenever we see that there is a loop which has been placed inside another loop, what does your brain say? I mean, we are tempted to say that the complexity is n square or something. Isn't it? Yes or no? That is what happens. We see loop inside loop, we say that it's going to be n square or something. But that's not always true. And that's not what is happening here. If I ask you to find out the complexity here, what will be the answer? What are your guesses? Let's say the length of the string is n. If it is n, then what's the time complexity in this case? N square or of n what? So I'll try to explain it to you in the easiest possible way. When you look at the stack, in this stack, all that is happening is either a character is pushed or a character is popped. That's all. That's all that's happening. Can you tell me what is the maximum number of times for which we touch a particular character? A particular character, how many, what is the maximum number of times it is touched? The answer is 2. It is touched first when it is pushed, and it is touched second when it is popped. Take example of this string only. Like you push P, you push Q, you push R, and now when you compare A with R, you realize that R is coming later and it is greater, so you pop this R. So the maximum number of times you are touching a character is 2 times. And you are doing push and pop. Push and pop, both of them are constant time operation. So I can say order 2 amount of work is being done for each character. And if there are n characters, then what will be total work? It will be nothing but 2 into n. And 2 is very, very small in front of n, so it can be ignored. And that way we can say that the overall complexity is linear, as some of you have said also. So order n is what is the time complexity for this problem. Okay, and this is how it can be easily explained. And now if you talk about space complexity, I would say that yeah, we are using a frequency array and a taken array of size 256, but on top of that we are also using a stack. Now the maximum size of this stack can be order of n, right? Because what if the input that we have is already sorted? So in that case, all these characters will keep on getting pushed inside the stack one after the other, one after the other. So I would say that the space complexity also here happens to be order of n. So both time and space complexities of this question are order n each. A beautiful application of stack data structure, isn't it? What do you guys say? Usually when we talk about data structures like stacks and queues, we feel like they are very simple. They might not be able to solve harder questions. But you see here how a simple data structure like stack has been used to solve a question like this, right? Okay, great. So by the way, how many of you have ever studied a concept of next greater element in array? It's a very well-known question where somebody asks you that, hey, find the next greater element for every element in an array. And you must have used stack to solve that, isn't it? I'm pretty sure about it. Did you find this question to be in exact same line as that question? I mean, the line of thought, the design, the implementation, everything was along the same track, isn't it? And so such kind of questions are said as questions that require monotonic stack. Here also, the stack that we created is monotonic only, monotonic as per this rule, that the characters are appearing in ascending order, and only if the frequency of a character is lesser, then it ends up coming after a greater character, right? Okay, great. So that's it. Just go back and try writing the code on your own. When you write the code on your own, then you will get much more clarity of things. But understand whatever we have used, why we have used a frequency array, why we have used this Boolean array, and of course, most importantly, why we have used this stack. Okay, cool. So I think that will be it for today. Let's see you all again tomorrow with the new question. Okay, bye, good night.